Alright, so our synthesis step is complete, the smell of bananas is strong in the air, and we're ready to move on to our extraction, which is the first purification step. The reaction mixture from the round bottom flask is transferred into a separatory funnel, and then that same flask is also going to be rinsed with a couple milliliters of diethyl ether. We need to add a total of 20 milliliters of diethyl ether. So once the couple mils from the rinse have been added to the separatory funnel, I went ahead and poured in the rest of the diethyl ether as well. Now that everything has been added to the separatory funnel, we put the cap back on and then take it out of the iron ring to start the shake and vent process. The first time you do this, you want to take the separatory funnel with your finger on the cap firmly and slowly invert it upside down, vent it, and then gently invert it and vent it each time. You'll notice when you vent the first few times especially, there's this little pop sound like you're opening a soda bottle for the first time. As that pop sound gets quieter, you can start to shake the separatory funnel a little bit more aggressively. Once you can't hear that sound at all each time you vent, that's when you know that you can stop the venting process and replace the separatory funnel in the iron ring. With the separatory funnel back in the iron ring, we can draw off the bottom aqueous layer into an Erlenmeyer flask. But it's not draining. If you notice, someone has left the cap on. Make sure you remove the stopper from the separatory funnel before trying to drain off your aqueous layer. After drawing off the first aqueous layer, we've gone ahead and added 10 more milliliters of sodium bicarbonate to the separatory funnel. We are going to repeat the process of shaking and venting as described earlier, again beginning with an inversion and then slowly working our way up to shaking the funnel. The purpose of this extraction is twofold. First of all, you started out with a lot of acid in your reaction flask, so you need to neutralize it using a base. That's why we use sodium bicarbonate. You also want to isolate your compound in the organic layer, which is why we add diethyl ether, our organic solvent. Now that we've drawn off the second aqueous layer into the waste flask, we can take our organic layer that we have isolated and transfer it to a clean Erlenmeyer flask as well. It's important to note that we are pouring the organic layer out the top of the separatory funnel, because if you were to drain it off the bottom, you would contaminate it. In that 50 milliliter Erlenmeyer flask with the organic layer, we are going to add a healthy scoop of magnesium sulfate. The purpose of mag sulfate is to dry the organic layer. Now that doesn't mean we want it to be a solid, that means that it is removing any residual water that is in the organic solvent still. You should get this sort of snow globe effect when you have the right amount of mag sulfate in your flask.